So we are continuing with numbers 14 and 15. They both use the same graph, the same data. I've been trying to change the numbers on them, but I didn't want to do that for this because there's a lot of numbers and they don't give us this list, they just give us the graph. I didn't want to redraw the graph or anything, so I'm just going to go ahead and stick with the numbers they give us and do that. Also, because for these questions, especially for number 14, we really can't answer the question. We have to read the answers and see which of the answers applies to what they give us. So we kind of don't have a real question asked in 14 so much as kind of the Jeopardy version where they ask us the answer is 50 million, what was the question sort of thing. So I didn't mess with number 14 at all. That's what we're going to do first. They gave us this graph, right? These, I left off when it cells, it's the cells in millions or billions, millions I think. Millions of dollars, we don't really need the millions of dollars, so I just wrote the 28, 23. This was the year 1995, 1996, 1997, etc., 1999, 2000. So I don't think that'll confuse anyone. We need the output values. And question number 14 asked, which of these following things, part A, B, C, D, whatever answer choice is A, B, C, D, which of the following ones has an answer of $50 million? Then they ask us for the median. Is that one of them? The median is the middle measurement. All right, for middle measurement, yes, I should have erased these. I'll explain what those are in just in a few minutes. Median is the middle measurement. So for answer choice A, we're basically checking to see if the median is equal to 50 million. I'm leaving off the million, so $50 million, that's kind of the question. Is the median or middle measurement equal to 50 million? So for the middle measurement, they don't mean middle this way. That's somewhere around here. We don't really care about that. We care about the middle this way. The millions of dollars are represented by the vertical axis, so we need to think vertical values and get the median of those. So I don't care about the 95, I care about the 28 that's associated with the 95. I care about the 23 that's associated with the 96. So I look at the numbers 28, 23, 42, etc. I need to rank those from either smallest to largest or largest to smallest. It does not matter which way I rank them. And we got to find a middle measurement this way and that way, right? I wrote lowercase n equals 10 because we have 10 different bars on this, 10 different years that they gave us sales values for. So we're looking for the middle measurement out of 10 ranked ones. And just like in the previous question, if I'm getting the position, that position is going to be n plus 1 divided by 2. N is 10, so 10 plus 1, 11 divided by 2 is 5.5. So we are going to be between the 5th and the 6th. And we should be right exactly in the middle. When they give you formulas for these, for how to find medians and things of this nature, they just go exactly in the middle on one of these. So we're going to count and get the 5th and the 6th. 1, 2, 3, 4, 5, 6. So between the 40 and the 42. And I would have gotten the same thing had I gone this way, largest to smallest, first, second, third, fourth, 5th, 6th. So it would have been at the same two values and it would have gone right in the middle of those. We're going to get 41 when we do that. So our median is going to be 41. It's not 50. Is it close? I mean, it's close-ish. It might be close enough. We want to check all the other ones and see, and basically go with the best answer. Range just the large minus small, largest minus smallest. Just like when people talk about range in real life, pretty much what they're referring to. Like you subtract the values and what's the total spread. For us, our largest is 60, our smallest is 20. So $40 million, 41, 40. All right, so we're looking for 50. Might as well be color consistent on this. We're looking for 50. Well, they're both kind of the same, but they're not quite what we want. Again, they might be the best answer. Mode. The mode is the most common. And for that one, 50 is the only value that's got a repeat on it. It doesn't mean the middle of the hump if you have some normal distribution continuous data set. It's the one that occurs the most often. 50 occurs the most often. It's exactly what they asked for, so that's going to be the one. If I look at D, D is the standard deviation. That's these numbers I had up here. I don't know what I did my first time through on this, but I decided to redo this one. And that's what these purple numbers I had up here were. Comes in handy at times to be able to approximate a standard deviation. Standard deviation, I'm going to use green up here. For a standard deviation, if you look at a formula, you kind of need the mean to do it. For the mean, I'd have to add all these together and divide by 10, and that's just too much work. I just want a ballpark figure. So that ballpark figure, maybe it's somewhere around 50. Who knows? It won't be anywhere near 50, right? But I only know that because I can look at these and say, now it's going to be a lot smaller than that. A way to get like a ballpark figure for a standard deviation kind of means what this thing is. Standard is just normal or to be expected, just kind of a routine sort of value. Deviation is how far something is from an expected value. I kind of want to see how far these measurements are from the mean, but if I'm just ballparking it, I don't really care to figure out the mean. So I'm going to take a guess at these and say my mean is probably around 40, and I'm going to just sort of even call this guesstimate. Because I'm not really doing a whole lot of math on it. I'm just looking at these and saying, well, it looks like it's going to be roughly 40 for the mean, whatever. 40 minus 20 is 20. Deviation, variance, how far away it is, that's 20 from what I'm guessing the mean is. This is 17 from what I'm guessing the mean is. This is 12. This would be 6 away from what I think the mean is. That's 0, that's 2, that's 10 away, that's 10 away. 53 minus 40 is 13. So these green numbers here are how far away the raw data, the 20, the 23, 28, etc., how far they are from my mean. And I know it's not super accurate because I just took a guess at my mean, but if my mean is a larger value, then these here are too small, but these ones are too big. So pretty much if I'm just in the ballpark, my errors on one side and the errors on the other side are pretty much going to cancel, and I'll be close enough for just doing a guesstimate on this, right? So if I look at these, I'd want to average these together. And again, I don't need to be super accurate. I have 10 measurements. If I just 20 plus 17, 37, 49, 55, 57, 67, 77, 90, 110. If I'm anywhere near that, right? 110 divided by 10 is 11. I could just look at that and kind of say if I just added those together and divided by 10, what would I be at? I'd probably get somewhere around 10, 11, 12, something like that. I punch the numbers into my calculator, and we actually get a standard deviation on this. My guesstimate was 11. If we actually ask the calculator, that's a 12.8 for what it is. So in reality, if I considered a population, we'd have about a 12.8. If I consider that to be a sample, a little bit bigger, sample 13.5. So they're giving a standard deviation of these values. If I just say how far from what I guessed the mean was, I guessed it was about 40. I could have guessed the average value of these and gotten somewhere around 10, nowhere near the 50 they asked for. Right? So you ought to be able to look at values of that nature. If you just write down a bunch of numbers on a bunch of values, you ought to be able to take it and say how far apart do they seem from, on average, to be from the mean. You ought to be able to get fairly close in terms of guessing a standard deviation sort of thing. If you can't, it's something that comes in handy to be able to work on a little bit if you're going to be analyzing data in any way. Anyway, that was number 14. And I guess I'll pause here and then go into number 15. Guess I will erase all this and do it again. 14. Probably ought to stop it for a minute.